In this video, we're going to graph a rational function, and we're going to do that in our problem journal. And before I get started, I want to remind you that you have a document, this blue page that we worked on in class, that is a reference document about all the things that we should consider when we're graphing rational functions. And this is a blank one, but you should have one that's been filled out. And if you don't, please go to the Graphing Rational Functions page on PowerSchool Learning and make sure that you have a copy of this and that you've gone through you've watched the 2 videos about how to fill this out. And that will give you a good foundation about graphing rational functions. And it's a good reference document to keep with you when you have to graph rational functions. So also the slideshow on PowerSchool Learning that contains this particular slide also has some practice problems on the second slide, and that's what I'm going to be doing here. So first of all, in a problem journal, we want to title this problem that we're doing by its topic. This is graphing rational functions. So graphing rational functions. And today's date is the 14th of November. And the rational function that I'm going to be demonstrating here is the very first one that we were practicing from the slideshow, from slide number 2 in the Graphing Rational Functions frame. And that's what it is. It's this function f of x, which is 3 divided by x minus 5. And just as when we do any graphing, we're going to start with a set of axes. There they are, x and y. And the first thing I want to do is locate any vertical asymptotes. Asymptotes are lines that the graph gets closer and closer and closer to, but never quite touches or crosses. And this particular function has a vertical asymptote at x equal to 5. And the reason is because if I put 5 into this function for x, then there is no output to the function. The function is undefined when x is equal to 5. And so I look for the values of x that cause division by 0, and I can locate my vertical asymptotes there. So here's where x is equal to 1, 2, 3, 4, 5 right here. And so I'm going to draw a vertical line at x equal to 5. That's my vertical asymptote, and I'm going to label it with the equation of that line, x equal to 5. Now, the next thing, in order to get the horizontal asymptotes, I need to consider the values, or what happens as x gets bigger and bigger and bigger and bigger in the positive direction. So in other words, we're considering the end behavior of this function. As x approaches infinity, what happens to this function? And notice that if I take a really large number like 1,000,000 or 1,000,000,000 and I subtract off 5, I really haven't changed that number very much. So this minus 5 becomes less and less relevant as the value of x gets bigger and bigger and bigger. So if I take 3 and I divide by a really, really big number, I basically get 0, or something that's very, very close to 0. It's a positive value, but it's very close to 0. So I expect that as x gets really large, this function gets closer and closer to 0. You can demonstrate this with a calculator by just plugging big numbers in for x and seeing what happens to the value of your function. We also want to consider the end behavior in the other direction. What happens when I put a really, really, really big negative number in here, like negative 1 billion? Well, the minus 5 again is not that relevant. If I have negative 1 billion and I subtract 5, it's still basically negative 1 billion. And if I take 3 and I divide by negative 1 billion, I get a very, very, very small negative number. Or I should say a negative number that's very close to 0. So from this information, I know that my function is going to approach this line. This is the line where y equals to 0. And that's my horizontal asymptote. I also, when I did that little thought, that mental math, I know that I'm going to approach this line from underneath because I'm getting a negative number that's getting closer and closer to 0. And over here, I'm going to approach this line as x goes towards infinity. I'm going to approach this line from the positive side because I get a smaller and smaller positive number. So I have enough information really now to finish this graph, but I want to do one last thing and just test a couple of points to make sure that I'm going to draw this graph in the appropriate quadrant. Imagine I put 0 in for x into this function. I would get 3 divided by -5, which is like -0.6. So I might just plot that point. X equal to 0, y equal to -0.6. It's somewhere like right about there. And that just confirms in my mind that this is the curve, the first piece that I want to draw of my function. So I know that the other piece is going to be here also because of the analysis of the end behavior of this function. But I can test a point also. Here's x equal to 5. Here's x equal to 6. If I plug 6 in for x, 6 minus 5 is 1. 3 divided by 1 is 3. So when x is equal to 6, y is equal to 1, 2, 3. I could just plot that point there. And again, that just informs where the other part of my function is. It's going to come down this way and go out like that. So notice the curves that I drew that represent this function, they get closer and closer and closer to the vertical asymptote, and they get closer and closer and closer to the horizontal asymptote. That's what an asymptote is. So there's the graph of the function f of x equals 3 over x minus 5.